We're going to talk about next some sort of history about how to interact with routers and switches and other networking devices in kind of an automated fashion. And that's what we're going to get into next. So here we've got Tickle or TCL. A lot of people call it Tickle. I call it Tickle because it's cool. Tickle and Expect. So we're going to talk about these. So Tickle was created by John Ousterhout, UC Berkeley in '88. Tickle is short for the tool command language, and its primary focus was glue code, basically tying together a bunch of like shell scripts or sed and awk and all kinds of Unix commands that by themselves worked separately with their own sets of inputs and outputs, but together it was sort of hard to make them work in concert, and that's why Tickle was created. Tickle's still used a lot today. So when I say testing here, it applies to both software testing. It also applies to network device testing. If any of you are familiar with network test hardware like Ixia, Spirent, whatever, any of those types of platforms, they run Tickle in their automated test suites. I think I also talk about some other use cases, or rather folks that use Tickle and a couple other, or in the next future bullet point. But rapid prototyping, meaning you want to like throw something together really quick as a proof of concept. Tickle is also really popular with GUIs. TK is the GUI toolkit for Tickle, and they're often seen in pairs because Tickle is also good for like event-driven code as well. Here we go. Tickle's really popular in embedded systems because it's very, very small. The footprint of it is tiny. So I know that the F5 iRules engine is written all in Tickle. Cisco IOS has an embedded event manager, which is Tickle-based. Again, Ixia testing hardware uses Tickle extensively to run its automated tests. Tickle is very popular. It's still in use. The syntax of it is a little bit cumbersome, a little bit dated maybe, but it's still a good language. Expect. I think there should. If you're a network engineer and you've like played around with coding, you should understand what Expect is. But we're gonna go over it anyway. So Expect all it is a Tickle extension. Okay, Expect is written in Tickle. It extends Tickle, and it was designed to automate interactive command line applications, right? So like Telnet, FTP, SSH, TFTP, anything where the user is going to be interacting with the application, like waiting on input, providing input, things like that. And Tickle was created to sort of automate those interactions. Expect is still used a lot because maybe there's some networks out there that don't have super high-end systems, or no Python available, or what have you. So Expect is used. There are downsides to Expect, which we'll talk about, but it's still very, very, very common because again, it can be used to interact with SSH or Telnet, and you can create sort of pretty easy Expect scripts to go and to automate an SSH session to a router or switch. Feed readback commands that are provided by standard out, or provided to standard out from the Expect script via the session, the Telnet or SSH session to your device, et cetera, et cetera. So there's some Expect's been ported to languages. Perl has a port of Expect. Python has a port of Expect. It's not just Tickle anymore, but the root of how Expect works is still the same, no matter if you're writing it in Tickle or if you're writing it in Python, Perl. It's called Expect because you send a command and expect a response back, and then when you get that response you expect, you do something else. That's why it's called Expect. Talk about pros. Expect is intuitive because it's easy to abstract. Oh, I'm going to send this command and I should get this result back. It's ported to both Linux, Unix, and Windows. And another cool thing about it Expect can be written as such so that you can automatically return control to the user at a given point, and then as a user you can return control back to the script. It's not completely automated, Okay? If you need to insert a breakpoint for whatever reason, you can do that with expect. Cons, it's not secure, okay? It's not. If you need to log into a device, you are storing those credentials to log into the device in the expect script. There's no other way around it. As far as I know, expect does not have any means to encrypt that data in the code. At least this was the case the last time I used it. Something may have changed, but I honestly doubt it. Dealing with prompts can be a pain. For any number of devices, you could have any number of prompts. Host names can do, if the host name for a device is especially long, it can do weird things to a prompt. And dealing with these edge cases, in which there could be a lot of edge cases, is cumbersome. The other con, expect is synchronous in nature, okay? So when I say synchronous, what I mean is that you can't just say expect, send this command and this command and this command and this command, and then I'll just wait for all the output, okay? So expect is a sequential operation, or uses sequential operations. You use expect to send a command, you wait for the output. You send another command, you wait for the output. It's send and receive, send and receive. It's not send, and then I'll just wait to receive it at my leisure. It's only synchronous as opposed to asynchronous.